The woman who discovered dark matter. This is High Story in the Shadow. Please subscribe our channel for amazing videos. Thank you. Let's start our thriller story. What if I told you that 85% of the universe is made of something we can't see, can't touch, and can't detect with any instrument? What if I told you that this invisible substance is the only reason galaxies don't fly apart? And what if I told you that this mind-bending discovery was made by a woman who wasn't even allowed into some observatories because of her gender? Palomar Observatory, California, 1965. A young astronomer named Vera Rubin climbs the stairs to the 200-inch Hale telescope, one of the most powerful telescopes in the world. She's about to make observations that will shatter everything we thought we knew about the universe. But there's a problem. The observatory doesn't have a women's restroom. Vera has to tape a piece of paper over the men's sign and create her own facilities. Little does she know, she's about to discover something that makes up most of the universe. Let's rewind to understand why Vera's discovery was so revolutionary. In the 1960s, astronomers thought they had the universe pretty well figured out. Galaxies were like cosmic pinwheels, spinning in space according to Newton's laws of motion. The theory was simple. Just like the planets in our solar system, stars in a galaxy should orbit faster when they're closer to the center and slower when they're farther out. It's basic physics, the same reason Mercury races around the sun while Neptune crawls. Vera Rubin decided to test this assumption by studying the Andromeda Galaxy, our nearest galactic neighbor. Using advanced spectroscopy, she could measure exactly how fast different parts of the galaxy were rotating. She expected to find what everyone expected: stars near the center moving fast, stars on the outer edges moving slowly. Instead, she found something impossible. The outer stars were moving just as fast as the inner stars. In some cases, they were moving even faster. This made no sense. According to everything we knew about physics, these outer stars should have been flung out into space long ago. The gravity from the visible matter in the galaxy simply wasn't strong enough to hold them in orbit. Imagine spinning a bucket of water over your head. If you spin too fast, the water flies out. That's exactly what should have happened to these stars. When Vera first presented her findings, the scientific community was skeptical. Maybe her equipment was faulty. Maybe she made a calculation error. Maybe she misunderstood the data. After all, she was challenging fundamental principles that had been accepted for centuries. But Vera knew her data was correct. She had checked and double-checked everything. The results were consistent across multiple galaxies. Something was very wrong with our understanding of the universe. Vera teamed up with Kent Ford, an astronomer who had developed an incredibly sensitive spectrograph. Together, they began studying galaxy after galaxy, measuring rotation curves with unprecedented precision. Every single galaxy showed the same impossible pattern. Stars on the outer edges were moving too fast to be held. Vera realized there were only two possible explanations. First, our understanding of gravity was wrong. Maybe Newton's and Einstein's laws of physics didn't work the same way on galactic scales. There was a huge amount of invisible matter in these galaxies, matter that we couldn't see, but that was providing the gravitational pull needed to hold the stars in orbit. The second explanation seemed more likely, but it required accepting something incredible. Most of the universe was made of something we couldn't detect. Astronomer Fritz Zwicky had actually proposed the existence of dark matter in the 1930s while studying galaxy clusters. But his work had been largely ignored. Vera's observations provided the definitive proof that Zwicky's dark matter not only existed, but was the dominant form of matter in the universe. Here's how mind-boggling this discovery is. Imagine you've been living your entire life thinking that you and everyone else made up the vast majority of the population. Then suddenly, you discover that for every person you can see, there are 5 invisible people you can't see. That's exactly what Vera Rubin discovered about the universe. For every gram of normal matter, stars, planets, gas, dust, there are about 5 grams of dark matter. So what exactly is this mysterious dark matter? The honest answer is, we don't know. We know it's not made of regular atoms. It doesn't emit, absorb, or reflect light. It doesn't interact with electromagnetic radiation at all. We can only detect it through its gravitational effects. Scientists have proposed several candidates. WIMPs, weakly interacting massive particles, hypothetical particles that rarely interact with normal matter. Axions, extremely light particles predicted by some theories of particle physics. Sterile neutrinos, a type of neutrino that doesn't interact via the weak nuclear force. Primordial black holes, tiny black holes formed in the early universe. Today, scientists around the world are conducting elaborate experiments to detect dark matter particles. Deep underground laboratories, shielded from cosmic rays, house incredibly sensitive detectors. The Large Underground Xenon Experiment, LUX, in South Dakota, uses a tank of liquid xenon to catch dark matter particles. When a dark matter particle hits a xenon nucleus, it should produce a tiny flash of light. So far, these experiments have found nothing. But dark matter's influence goes far beyond individual galaxies. Computer simulations show that dark matter forms a vast cosmic web throughout the universe. This web acts as a scaffolding on which galaxies form. Without dark matter, the universe would be a very different place. Perhaps a place where galaxies, stars, and planets never formed at all. In 2006, astronomers studying the Bullet Cluster found some of the strongest evidence for dark matter. The Bullet Cluster is actually 2 galaxy clusters that collided with each other. When the clusters collided, the normal matter, gas and dust, interacted and slowed down. But the dark matter passed right through without interacting. Gravitational lensing revealed that the dark matter was in a completely different location from the visible matter. This provided stunning visual proof that dark matter is real and separate from normal matter. Vera's struggle as a woman in science, Vera Rubin's discoveries, came at a time when women faced enormous barriers in astronomy. Many observatories didn't allow women to use their telescopes. Vera was often the only woman at scientific conferences. Despite making one of the most important discoveries in modern astronomy, Vera never received a Nobel Prize. Many scientists believe this was a grave injustice. Dark matter has revolutionized our understanding of the universe in ways that go far beyond galaxy rotation. It explains how galaxies formed in the early universe, the large-scale structure of the cosmos, the cosmic microwave background radiation, the formation of the first stars and planets today. The search for dark matter is one of the biggest challenges in physics. The Large Hadron Collider at CERN is trying to create dark matter particles by smashing protons together at incredible energies. Space-based telescopes like the Hubble Space Telescope and the James Webb Space Telescope are mapping dark matter's distribution throughout the universe. Theoretical physicists are developing new models to explain what dark matter might be and how it behaves. Some scientists have proposed alternative explanations for Vera's observations. Modified Newtonian dynamics, MOND, suggests that gravity behaves differently on very large scales. But most evidence supports the existence of dark matter. The cosmic microwave background, galaxy formation models, and gravitational lensing all point to the same conclusion: dark matter is real. Think about what Vera Rubin's discovery means for our place in the universe. We are made of ordinary matter, protons, neutrons, and electrons. But ordinary matter makes up only 15% of all matter in the universe. We are the minority. We are made of the rare stuff. The universe is dominated by something completely alien to our experience. As if dark matter wasn't mysterious enough, Astronomers have since discovered dark energy, an even more mysterious force that's causing the universe's expansion to accelerate. Together, dark matter and dark energy make up 95% of the universe. We live in a cosmos dominated by things we don't understand. Vera Rubin died in 2016, but her legacy lives on. The Vera Rubin Observatory, formerly the Large Synoptic Survey Telescope, in Chile will survey the entire southern sky every few nights, creating the most detailed map of dark matter ever made. Scientists believe we are on the verge of major breakthroughs in understanding dark matter. New experiments are becoming more sensitive. New theories are making testable predictions. When we finally understand dark matter, it could lead to technologies we can't even imagine. Just as the discovery of electromagnetism led to radios, computers, and the internet, the understanding of dark matter could revolutionize civilization. Vera Rubin's discovery is one of the most humbling moments in human history. We thought we understood the universe, but we were wrong. We're like ants trying to understand a vast city, and we've just discovered that 85% of the city is invisible to us. The next time you look up at the night sky, remember Vera Rubin. Remember that the stars and galaxies you can see are just the tip of the iceberg. There's an entire invisible universe surrounding us, influencing everything we can observe. A woman who had to fight for the right to use telescopes ended up discovering that most of the universe is made of something we can't even see. She showed us that the cosmos is far stranger and more wonderful than we ever imagined. And the best part? We're still just beginning to understand her incredible discovery.